It's Saturday, the 16th of April. My name's Juan Brown. You're watching the Blanco Lario channel. And on Wednesday, the 13th of April, a young cargo pilot lost her life while flying a UPS feeder freight flight in a Cessna Grand Caravan 208 into the airport in Burley, Idaho during a snowstorm. If we look at the big picture, young Brittany Infinger was put in a very tight spot. A relatively low-time pilot, building hours to get the 1,500-hour minimum to achieve an ATP rating, flying single-pilot IFR in a Cessna Caravan aircraft that was well-equipped for that operation in icing conditions during a snowstorm with the weather at minimums into an uncontrolled airport, flying a non-precision approach during the day with obstacles surrounding the airport. This was Brittany's second approach after going missed on the first time, putting Brittany in a very tight spot. From the Aviation Safety Network, this accident occurred on 13 April. A Cessna 208B Grand Caravan 2013 model with the Pratt & Whitney PT6A engine crashed just 0.4 of a mile northeast of Burley Municipal Airport. That's right on line with the final approach for runway 20 on a cargo flight. The Cessna 208B Grand Caravan crashed on the roof of an industrial building in Hayburn, Idaho, while attempting to land at Burley BYI Airport. The aircraft departed Salt Lake City at 700 hours local time on the cargo flight to Burley. Flight tracking data show that the aircraft aborted the approach to runway 20 at Burley at 8:11. The aircraft lined up for a new approach. The accident occurred during the second approach as the aircraft crashed 700 meters northeast of the threshold of runway 20. At the time of both approaches, visibility at the airport was limited due to snowfall. Here's the METAR report. Here's the worst of the weather at 14:10 Universal Time. That's Greenwich Mean Time, or 8:10 local time. Winds and this is an automatic weather report from the ASOS. Winds 190 at 8, so about an 8-knot headwind. 1 statute mile of visibility in light snow and mist. Broken at 2,300, overcast at 2,800. Temperature minus 3 degrees Celsius, dew point minus 5 degrees Celsius. Definitely freezing conditions and that narrow temperature dew point spread leading to mist in the area. Altimeter 29096. From Catherine's report, we have a couple of pictures. Here's one of the aircraft on top of the Gem State Processing. This is a Idaho potato processing plant located off the end of runway 20 with what appears to be the left wing laying parallel to the fuselage of the aircraft being upside down. A picture of the aircraft before the accident, and a general picture of the area where the aircraft ended up. Here's an important picture that shows a little wider view of what happened. It appears that the aircraft struck this tower here, where the ladder is folded in. I assume that was the right wing of the aircraft hit this tower here. Investigators will be able to figure that out quickly, with the rest of the aircraft ending up right here. This aircraft would have been proceeding from right to left on this photograph en route to the final approach for runway 20. This tower is located well below the minimum descent altitude for this approach and well below a normal glide path angle, visual glide path angle for the approach to runway 20. So we know that the aircraft went below minimums. We know the aircraft simply flew too low for this approach, but we do not know why, and we may not ever know why this aircraft was so low at this point in the approach because we simply do not have the data. In the G1000 avionics suite, there is an SD card that fits in the top of the G1000 avionics. There may be some data there that investigators can extract, but to try to figure out why this aircraft went this low, this far out, a half mile out or so, 2,000 feet or so from the end of the runway, remains to be figured out. Investigators should be able to figure out pretty quickly if the engine was producing power or normal power at the time of the accident, and also how much fuel was on board the aircraft at the time of the accident. Given the flight profile of doing the flight, the approach, the missed approach, and the second approach, there should have been plenty of fuel load planned for this flight to do this. Investigators will also need to find out how much icing came into play in this accident. The Cessna Caravan is equipped with de-ice boots. It is equipped to handle this sort of weather. So investigators will need to find out that to ensure that was the de-icing equipment working correctly, and could it have been a factor on this approach. Icing is always a challenge to investigators because the evidence melts. At this time, there was no calls of any distress from the pilot. Investigators will be getting the ATC audio tapes from Twin Falls approach. Since Burley was an uncontrolled airport, there's probably no recorded information from the ATC calls, from the radio calls from the pilot coming into Burley. Here's the Burley Airport on Google Maps, located right at the banks of the Snake River. Two fairly short runways, about 4,000 feet long. Runway 20 was the runway that Brittany was flying the approach to, with the winds coming out of the south. And here is the potato processing plant that the aircraft ended up on top of. Right about here. And right here is the tower that it appears that the right wing struck. If we take a look down at the street view, right about there, here's the tower that was struck. There's the ladder, and it's before condition, and the aircraft ended up right about here. And there's additional smokestacks, and these smokestacks are located and shown as obstacles in the instrument approach procedure. As we go down the road towards the airport, here's another set of stacks that are located on the instrument approach procedure. Down here on 7th Street on the opposite bank of the Snake River from the runway, there's the end of runway 20, so kind of a bit down in a bit of a hole there. Here's another obstacle, the railroad bridge to the right of centerline. And as we turn around and look towards the final, here's the potato processing plant. Here's one set of stacks noted on the instrument approach procedure, and here's another set of stacks right here. This accident occurred somewhere right back in here. Looking at the runway information for Burley on AirNav, runway 2 and 20. Runway 20 is 4,140 feet long, just 80 feet wide. It does have runway lights. It does have runway end identifier lights, but it doesn't have touchdown point lights. It does not have a VASI, a visual approach slope indicator, for runway 20. There is a VASI for the opposite runway, but not for 20. And they mentioned the obstacles, a 60-foot stack, 2,050 feet from the runway, 100 feet left of centerline, a 30-to-1 slope. And runway 20 requires a 39-to-1 degree slope to the displaced threshold. For every 39 feet out, you have a rise of 1 foot to clear all the obstacles that we talked about in the Google map photographs. This is the approach Brittany was using to get into runway 20. This is a tricky, non-precision approach. There's a lot of little built-in problems with this approach that are subtle to see just from looking at the approach plate here. Non-precision approach means there is no positive glide path guidance into the end of the runway. There's no positive glide slope. Non-precision approach means you only have a precision lateral guidance, and otherwise you have to step down through these various altitudes and level off at what's called an MDA, an LNAV MDA, that's lateral navigation, minimum descent altitude, and you have to maintain that minimum descent altitude until which time that you have visual reference to the runway, to the landing area. You need to be able to see the runway before you descend out of this 4,560 foot altitude MSL. The minimums for this approach are 1 mile. Over here it says 501. She just had 1 mile, barely 1 mile of visibility. The problem with that is you can see the ground below you. That ceiling was fairly high, but you cannot see ahead very well. The slant range visibility through the snow showers makes it very difficult to see. The natural human reaction in low visibility conditions, even during the daytime, is to want to duck down. You want to naturally duck down below the weather to try and get a better view of the runway ahead of you. Single pilot IFR compounds this problem because normally in airline top operations, we have two pilots, a pilot flying and a pilot monitoring. The pilot flying is flying the gauges, head focused on the gauges, staying on the gauges. The pilot monitoring is backing you up on the gauges, but is also able to take peeks outside and help monitor your visual progress to the end of the runway, and then can give you verbal cues as to what he sees while you concentrate on the gauges. As single pilot IFR, this is very challenging because you have to split your attention between those two. This is not a contact approach. You cannot see the ground and then descend down to get closer to the ground before you see the runway landing environment. You have to see the runway landing environment before you descend out of MDA 4,560 feet, which puts you 408 feet above the runway. Remember, this runway is only 4,092 feet long. If you need to also be in a safe position to land before you can descend from your MDA. Even if you see the airport in this approach, you may very well be too high, too close to the airport to make a safe descent and land in the runway remaining. And one of the clues to that is this little note right here, this little angle sign, 3.75 degrees, threshold crossing height of 40 feet. That's telling you that this is a steep approach because of the obstacles that we talked about. That is a steeper than normal approach. Your typical glide slope wants to be 3 degrees into the end of the runway. Here's another little subtle gotcha with this approach. VGSI and descent angles not coincident. All right, visual glide slope indicator. There is no VASI for runway 20. I'm not sure what that references other than a plain visual 3-to-1 glide path angle to runway 20. There is no VASI to help you find this runway. Red over white, you're all right. Red over red is not good. There is no VASI for this runway. In other words, they're saying the normal descent angle for this instrument approach procedure is going to put you above a normal glide slope. You're going to be naturally unstable on this approach. It's going to force you into effectively an unstabilized approach. Remember, a stabilized approach, you want to be at 1,000 feet, all fully configured on speed, on glide path, that 3-degree glide path. In this case, you're going to have to come down, level off until you see the runway, and then do a relatively steep approach into runway 20. Now, the Cessna Caravan can fly low and slow, and that 4,000-foot runway length is not a problem, but in limited visibility, it can be. Note also, where's the missed approach point for this instrument approach procedure? It's right at the end of runway 20. You're 408 feet above runway 20, right over the threshold, and it does have a bit of a displaced threshold for the obstacles, but that's still much too high to make a safe landing from. Even if you saw the runway at the missed approach point, you would be forced to go around, and that's probably what happened to Brittany on our first go around. We'll take a look at the data here in a minute. So what weather do you use for this approach? Well, here's the automatic weather reporting station on 135.575, which will give you the weather you need for this approach, and the altimeter setting. And there's a small note in here: if that local altimeter setting is not available, you got to use Twin Falls approach altimeter setting, or the altimeter at Twin Falls Airport, and increase the minimum descent altitude by 80 feet. The missed approach for this approach is climbing left turn to 7,000 feet to Ermey and hold, which Brittany did on the first go around, the first missed approach. A min-safe altitude of 11,600 feet within 25 nautical miles of the airport indicates that there is some tall terrain within 25 nautical miles of this airport. Down here is where you see the small note about runway and identifier lights for runway 20. And that's about all you have for lighting on runway 20. Now, there is a second option here at Burley, but it is a circling approach, a VOR alpha approach, which will bring you down to 4,640 feet, about 486 feet above the ground, and then you could do a left base circle to land runway 20, but you still got to overfly the potato plant, and that requires quite a bit of maneuvering in low visibility conditions. I agree with Brittany that I would have taken the straight-in approach for a more stabilized approach into runway 20. If we take a look at the NOTAMs for the airport, we see a brand new NOTAM just 4 hours after the accident. Obstacle numerous building lighted within an area defined as a half-mile radius of, and they give it's the approach end of runway 20, 4,230 feet, 80 feet above the ground, not lighted. And they give the coordinates for that obstacle as well. They also have their permanent NOTAMs here explaining some of the other notes that we saw earlier. For example, delete note, vertical glide slope indicator and descent angles not coincident, because there is no VASI on runway 20. All of this approach planning and obstacle clearance requirements are done through a branch of the FAA called TERPS, Terminal En Route Procedures, and it's all done with mathematics, and they've carefully map out exactly where the obstacles are in relationship to the runway, and they build the approach with the required amount of clearances to clear all of these obstacles. And then periodically the FAA test flies these approaches and make sure that the approach procedure as published is current and legal, meeting all of these TERPS criterion. And I'm sure when you look very closely at this particular approach and those towers, the towers that were involved in this accident, you will find that those towers were within the TERPS criteria obstacle clearances for this approach. Now, whether that tower was lighted or not may be a point of contention. Was that tower small enough to not require a light to be on it, the tower that Brittany hit, or was it an option to have a light on that tower? I bet you that tower gets a light on it now. Now let's take a look at the preliminary ADS-B data from FlightAware. Again, this is rough ADS-B data showing ground speed and altitude. These altitudes can be off by a good 100 feet or so on the ADS-B data, shown here on FlightAware, because of numerous factors. So she's getting vectored in for the first approach to runway 20. She makes that approach into 20, goes missed approach as published out to ERMI, vectored back around for a second approach into runway 20. The accident occurs. So let's take a close look at this altitude data from the ADS-B data on the first approach and on the final approach. Remember, looking at the instrument approach plate, the MDA for this is 4,560 feet. Again, this altitude information may or may not be exactly correct, but here's the first approach: 4,700 feet, 4,600 feet, 4,500 feet. All right, 4,560. She's right at the MDA. 4,400 feet, and then back up to 4,500 feet on the missed approach. So just slightly below minimums. Also check out the speed. We're showing 136 down to 136 miles an hour ground speed, a pretty fast ground speed on that first approach for a Cessna Caravan. That high ground speed coupled with a high glide path means you're not in a safe position to land the aircraft. She may have gone around from that first approach because of a too high and hot situation rather than not being able to see the end of the runway. We don't know, and we probably will never know. On the second approach, 4,700 feet, 4,600 feet, 45, 43, 42, and then right into the ground at the location of the potato processing plant. Let's take a closer look at the track log. Right down in here, we see the first approach. We've got altitudes dropping down to 4375 is the lowest altitude, 147 miles per hour ground speed at 4375. So a bit below the MDA and pretty fast. And then slowing the ground speed down once starting to climb out. On the second approach, 49, 47, 44, 50. That's below the MDA of 45, 60, and then 41, 50. Brittany had recently graduated from the ATP school in Mesa, Arizona, getting her commercial instrument multi-engine instructor pilot rating back in May of 2019, and was building up her hours to 1,500 hours, the minimum requirement for an air transport pilot rating, so that she could apply for the airlines for a airline flying job. When you come up through the ranks in the civilian world to build at 1,500 hours, you have paid your dues. Thanks so much for your support of this channel, especially over the folks on Patreon that make this content possible. See you here.